Aniko is an assistant professor at the University of Zurich, where she leads the social computing group.
Just to super quickly mention my background, so I studied math and sociology, and then ended up in a computer science PhD, and basically I investigate socially relevant questions with the help of computer science or other quantitative methods. And I thought instead of picking one paper, I will sort of go through a line of papers in different domains, which represent the type of work that I do on so-called algorithmic auditing. And I will just focus on the takeaways of these papers. And not even in terms of results, but I think I wanted to focus on methodological challenges because maybe that's what's the most useful to such a diverse audience. Okay, so about 10 years ago, when I got into research, was when the first concerning examples of potential harmful effects of big data algorithms started to appear in the popular media. And at the time, these examples were mostly about the harmful effects of personalization. So you might be familiar with the concepts of filter bubble effect, where Google shows us only results that align with our views, or echo chambers, or price discriminations. So this is all due to side effects of personalization. But since then, actually, we're kind of flooded with scary news on this topic. For example, racial biases in the ads that are served by Google and Facebook, or articles warning about discrimination in the black box algorithms used for predictive policing or making parole decisions, discrimination on Uber, Airbnb, and so on. So there's really millions of examples for this. But I guess the question is, where is all this coming from? So let me show you first how I model the ecosystem that we're talking about and that I'm focusing my research on. So over the past 10, 20 years, there's this new ecosystem that has been forming on the web. Basically, web-based services and phone apps are constantly competing for our attention. So basically, everything we used to do offline, reading news, socializing, banking, healthcare, and so on, is now possible to do online. And there's this giant ecosystem of apps and online content supporting this. But of course, the companies behind all this content make profit from us interacting with the platform. So they try to find ways to make us more engaged, to spend more time on the platforms, to find the best content for us, basically to get more likes, views, and so on. And so what's happening is basically users are interacting with these websites. This is generating some data about the interaction between the user and the platform, which is then, so things like what we buy online, what we search for, our health data, and so on. And then all of this is fed into so-called big data algorithms. And the goal of these algorithms is then to personalize the content for us, figure out what's the most interesting to us. And of course, the more users interact with the platforms, the more these companies know about us, and the better these algorithms can tailor the content, which in the end might lead to two different users seeing completely two different versions of the web. And basically in this cycle, there are two boxes that are completely unknown. So one of them is what data is generated about us, and also what are these algorithms actually doing with the data to tailor the content. And so this is what all my research is basically about. Try to understand these two black boxes without having real access to it. I mean, having access to data from the companies. So in very short, my work focuses on the co-evolution of users, content, and algorithms in online platforms. of course, as these systems interact with humans and their algorithms learn from human data, they are bound to recreate the issues that we know from the offline world, for example, inequality or segregation. So I'm curious how these problems known from the offline world can transfer to the online systems, and how the algorithms then retain or potentially reinforce them. And as I just mentioned before, the data and basically how the algorithms work is mostly proprietary. So I'm actually trying to develop tools that allow us some transparency about how the systems work. And given the new context, the online context, we need to adapt the traditional methods, or in some cases come up with completely new methods. But my main goal here is basically to inform users, create awareness about what's going on. And of course, in many cases, there's also a legal aspect. So I'm trying to inform policymakers. And finally, I, of course, don't only want to find problems, but also try to find solutions. So more recently, my work is focusing on mitigation strategies, or kind of testing changes to the systems to overcome known issues. Okay, so in this talk, I will show you some example studies from various socioeconomic sectors, hopefully give you an overview of the kinds of methods and challenges that we deal with. And the first topic I will focus on is personalization algorithms. So I probably don't have to convince you that personalization is everywhere. Here are some examples how it looks like in practice. In most cases, it's of course very useful that we get personalized content. I don't really want to see restaurants in Zurich when I'm visiting Milano, but there's also potential downsides to it. For example, as I mentioned, echo chambers, filter bubbles, price discrimination, and so on. So the example that you see here is an example about the filter bubble. And this is the example that was given by Eli Pariser a very long time ago, I think more than 10 years ago. He was the first one who started talking about the concept of filter bubbles. You see basically two Google searches here, one by sort of a normal person, and one is by someone who is really into traveling and searches for tourist information all the time. And this is why among his top results, all he is seeing is links about traveling. And this means that even if there's important political events going on in Egypt, like in this case, these people might have no idea what's happening when they just look, at the first page of the search results. And this example was actually reported by people, and in fact, at the time of the Arab Spring, so you can see how it's pretty drastic. And this means that it's not just relevant information that might not be reachable, but what makes it worse is that the people it's happening to actually have no idea that there's all these algorithms tailoring the content that they see, and they might be missing out on something important. And so at the time when Eli Pariser wrote this book on the filter bubbles, it actually coincided with me starting my PhD, and there was absolutely no research on this. So there were quite a lot of articles popping up warning people about this, but basically they were all based on examples like this one, or very, very small scale experiment. So basically what I set out to do in my PhD was to create large-scale experiments to actually test how often is this happening, how statistically significant it is. And first I focused on Google, but then later I started recreating them in different contexts. So why is it actually hard to have an idea about how personalized the content we see is? The simple answer is that we basically only see what we see, so and not what other people see. So I could, of course, now ask you to all Google the same thing at the same time and compare the results. But you could still argue that, you don't see as many differences because, at least this is true for the people in Milano, because you're all sitting in the same room and you have the same IP address. Or you could even argue the opposite, that you don't see as much, or you do see the differences, but it's because you didn't search at the same time exactly or something. And this is where the differences are coming from. So my point is that while conceptually it's quite a simple thing, when you think about personalization, it's actually pretty challenging to measure it. And also for a single user to even realize that it's happening to them. So in this example, I was searching, that you see here on the screen, I was searching for a product on Amazon, and I'm trying to figure out how personalized the resulting content is. And if I run the same query from two machines, if basically I'm running two searches from two different machines, and they return for the same things. Amazon returns with some product, and then I'm trying to see what the differences between these two pages are. But the problem is that even if I see differences, I cannot say that it's necessarily due to personalization, because there's a lot of different effects that could be going on here. For example, updates to the inventory and prices, or text differences, or there could be some kind of internal load balancing going on Amazon side, or they could even be doing A/B testing. So this is why we need to very carefully design large-scale experiments. And on top of this, companies obviously don't help. So we don't have any information about the algorithm, can't really experiment with it, only observe the output that they give to us. So this is what makes the measurement as an outsider very challenging. So basically, my main question was, how can we reliably identify and quantify personalization? And for this, the method me and my coworkers at the time came up with to measure these systems as an external observer is called algorithmic auditing. And the idea behind algorithmic auditing is to manipulate the content that goes into the algorithm and then look at the content that comes out of it and basically try to figure out what happens in between. So the main questions that we typically want to answer are, first of all, to what extent is the content personalized? So when we're talking about Google, out of the 10 results, how many do I see because it's me, and how many would also other people see? And then the second question is, why is it happening? So what are actually the features behind the personalization? Am I seeing certain results because of my gender, because of my location, because of my political views, and so on? So let me just quickly tell you at a high level how we try to answer these two types of questions, because they actually require different methodologies. So to answer the first question, to what extent content is personalized, we basically have a bunch of people run the same searches at the same time under as controlled circumstances as possible. And then we basically compare the results that they get back. So the results that I would get for a question like this in the context of web search looks like this. So to tell you more practically, we hired 200 people through Amazon Mechanical Turk to run the same searches for us, of course, automatically. So they just opened up the browser and these searches were running automatically in their browsers while they were actually logged into their accounts. And for every search they did, we also ran a search in an empty browser at the same exact time with no history at the same time. This was meant to be basically a control. So this plot shows on the y-axis the percentage of results that are different across the two accounts, and the x-axis shows each rank. There are 10 results on each page. The top is 1, the bottom is 10, so this is why you see the 10 bars. And the reason you see blue and red is because the blue is basically showing the difference between these control queries that we ran. So the ones that were ran on an empty browser. This is meant to measure kind of the underlying noise in the system. So how much difference do you get if you have completely the same circumstances? But what you see above that in red is what we can definitely call personalization, because it's kind of the personalization above the noise. So the main takeaway is that we found 12% personalization for Google on average and 16% for Bing. And the differences are more common towards the bottom of the page, as you would kind of expect it. But this was something like 10 years ago or 8 years ago. So the results are obviously not up to date. So the emphasis is less on actually the results here, but I wanted to give you an idea what kind of results do we even expect from this type of data collection method. And so now that we have an idea of what we see in people's browsers, if we really look for kind of how much personalization is there overall, we can go back to the second questions. Why do we see all this personalization? We're naturally interested in why people see these different results. And that's a bit trickier to get to. Because if we now look at the data that we already collected, it's going to be very hard to disentangle all the different effects that are going on. So what we do here is we basically replace real users with synthetic accounts, which we are able to control and browse through them automatically. So this allows us to measure the effect of specific features that we're interested in. So for example, to measure the effect of gender, I would create some male and some female accounts, and we make them behave otherwise exactly the same, and then collect some data through those accounts, and then the difference that we observe would be specifically attributed to the gender attribute. Maybe to give you an idea what kind of features we generally test. Basically, in the case of web search, there's 3 types of features that we are interested in. There's the static features, which you basically provide at the time when you create your account. For example, the gender, the age, the name, the zip code, and so on. It might be the case that by now you have to provide different information when you create an account at Google, but these were the ones at the time. Then there's features that we call query features. These have to do with basically anything that you signal at the time of the search. So what operating system you're using, what kind of browser you're using, what is your location, whether you're logged into your account or logged out, And then finally, and this is what I sort of expected to see the most differences from, there are some historical features. So basically the profile that you build up over time. What kind of things have you searched for in the past? What did you browse for on other websites? Google is actually tracking a lot of our behavior on different websites as well. Or also which results you're clicking on. And actually with these historical features here, we did something quite exciting. So we tried to imitate the behavior of specific demographic groups. So we had different age categories, education categories, and so on. And we had some data on how these demographic categories would typically behave, and then tried to actually trigger or signal this behavior to Google. And then basically for each of these experiments, I created a bunch of fake accounts that were assigned with these specific traits or behaviors. And every day, at the end of the day, they would run 120 queries. And then basically this would serve as the data set for comparing how much differences we actually triggered. Maybe something important to mention or funny to mention is that I ended up using hundreds of fake accounts for these experiments, and it was very unexpectedly difficult. So this turned out to be kind of a weird bottleneck in the project. It turns out it's super hard to create fake accounts for Google. Yeah. So we turned to all sorts of tricks to be able to actually create more and more of these fake accounts, and they kept blocking us. And there were times when we basically blocked Google for the whole department because of this. But so what turned out to be the most determining in terms of personalization was users' location and whether they are logged in at the time of the search or not. Basically, the short takeaway is that Eli Pariser was maybe a bit too worried, or at least by the time I did these measurements, Google had maybe focused their personalization efforts on other products, for example, maps on YouTube. But it turns out that those extreme examples are quite rare that are usually shown in the media. Okay, so let me jump to a different sector here, namely online retail. So in this project, I created very similar experiments to Google and Bing, but on online stores. So if you think about it, when you go on the website of an online store, it's quite similar to search, right? You search for a product and then you get a list of products back. And I repeated basically the same type of measurement on 10 online stores and 6 travel sites. And I focused on the products and the prices that are returned by searches. Price discrimination can actually occur in 2 forms. One is when the prices are different for the same product, or sometimes what these sites do is that they just give you completely different products. And maybe those different products have on average very different prices. So this is what we call site price steering. The result in one sentence is that on most sites we found some form of personalization, either different prices or different ordering of products. And sometimes the difference was up to hundreds of dollars, especially in the case of reserving hotels or cars. And the reasons really highly varied. So it could be the operating system or browser, or owning an account versus not owning an account, and so on. But I think more interesting than the results is actually really the infrastructure that we had to build for this. Because we had something like 30, 40 browsers simultaneously running these automated searches for months and months. And I'm not saying this to brag, but basically because I want to say that tracking price discrimination is really not an obvious thing for policymakers who want to test whether a site is doing price discrimination or not. There is actually a law in the EU that in online stores in every single country, you have to actually provide the same prices for the same products. But this is, as you can see, basically impossible to test for every single site. And in fact, after this paper, the EU Commission reached out to us repeatedly with requests to audit certain platforms. But it was every time it was kind of based on a hunch already. So I think they're really struggling to create these types of measurement systems more generally. And maybe another interesting thing to think about is that it's not even obvious for the platforms themselves to test or to monitor their own behavior. So even if they wanted to have a completely fair system, they would have to dedicate a lot of extra staff to creating these measurements and monitor themselves all the time. Maybe naively, you might think that that this type of price discrimination doesn't happen if it's not meant to happen, but that's not really true, because we actually found, even in these examples, a lot of cases where we had the feeling, okay, something is really just like probably one engineer did something on accident that creates these huge discrepancies, and the website might not be even aware of it. And of course, it's more easy for something like Google or Bing to dedicate some extra effort to do these types of measurements. But sometimes these online stores that just sell one type of product, they were maybe built by 3 guys in a basement, and they really don't have these extra efforts to do this type of monitoring. Okay. So with this, I'm going to conclude on the personalization part of the talk. And in the second part, I want to mention a different scenario in which big data algorithms might have a huge effect. Namely, when the content owned by the service providers is actually about people directly. So, for example, on job search sites, dating sites, or many other social sites, people willingly provide personal information in the hopes of getting better services. So this personal information, of course, triggers stereotypes and biases when we decide, for example, who to hire or who to date. And combined with the algorithms, this might result in reinforced discriminatory effects. And I think it's a very important distinction that people here share their data willingly, because we might think that it's in our control what data we give out. But if everyone uses LinkedIn, of course, I'm also going to use LinkedIn, and I'm going to feel like the more I share, the better my chances to get a job. So of course I will share this data, and I can't really get out of this loop of whatever information I share triggers certain biases. So one of my major interests among these online services are employment-related platforms, because the labor economy has gone through really drastic changes. In the last years, people are searching for jobs online. Online freelancing is more and more common, and so on. And it's also maybe a good example for a sector where regulations are in place for a long time. So the process of regulating this sector took hundreds of years to protect workers, but suddenly policy making has to function in online context and has to catch up very quickly and make sure to protect employees online. And the lack of transparency and understanding about what's actually going on these platforms and how algorithms work can really hinder this policymaking process. So I will show you a couple of examples of labor market related questions in digital spaces. I'll start with job search. So I'm sure you also have a profile on some job search site or academic social network. And while we might think that LinkedIn, for example, is a place or a tool to find a job, and there's also another side to it. It's basically a giant database for recruiters to find us. And so companies pay actually thousands and thousands of dollars per month to get access to this database of potential employees. So that's where the real business is actually happening. And what you see here is basically the perspective of a recruiter who has access to a database on one of these websites. We didn't manage to get access to LinkedIn because it costs so much to sign up for it, but we got access to 3 different websites that are quite big in the US for job search. So this is called Indeed. And so basically, if you're a recruiter, you can search for, in this case, software engineers in New York City. You can set a bunch of different filters based on experience, skills, and so on. And then you get a bunch of results that are people. Usually you get thousands of people, actually thousands of profiles here. These results are ordered according to some relevance. And this is where the algorithm comes into the play again. It will basically try to figure out who are the best matching people for our search or our taste. And we have actually no idea how relevance is determined, but it will, of course, influence who has the best chances to be seen and who has the best chances to get offered. And while demographic information is not explicitly taken into account, the worries that, of course, some features will correlate with gender or race and other minority groups, and minority groups end up lower in the result list. So the question I asked in this project was whether gender and race are related to where people are placed by the algorithm. And unfortunately, the answer is yes in many cases, even if we control for their experiences on the job market. So what I did was I went ahead and signed up for 3 of the biggest job search sites as recruiters. So basically pretended to be a recruiter and got access to this data. And then I ran searches for 35 different job titles in 20 different cities. And yeah, I made sure to have a variance in kind of what type of jobs I'm searching for. So both high-skilled jobs, both low-skilled jobs, and also jobs associated more with women or more with men traditionally. And basically, out of this data, I extracted, first of all, sorry, maybe what I should have mentioned is for each of these searches that I ran. Okay. So for each of these searches that I ran, I basically captured all the returned profiles, and not only in the list as it's shown, but then I went on the user profiles of all these people, and saw also what kind of descriptions they have about themselves and CVs and so on. So basically, this allowed to get user features such as people's location, name, gender, and so on. Their job-related experiences, for example, education, other experiences, current job, and so on. How relevant they are to the query itself. For example, the relevance of their current job title to the search that we did, and so on. And then finally, where they showed up in the search result list. So basically just where they were placed by the algorithm. And when we look at this ranking bias, we see that there are significant differences in the distribution of men and women. So on average, 18, 13, and 18, respective, the website of these job title and city pairs. So for jobs such as cab drivers, software engineers, or cashiers, it's even higher, which means that in terms of groups, basically, so on average, the situation is not fair. But this, of course, doesn't necessarily mean that the algorithm is unfair. So let's see what happens if we only compare women and men with equal qualifications based on every observable characteristic that we see. And for this, we built a so-called mixed linear regression model on the users, where we set the logarithm of the rank as the dependent variable, and all other experience, education, demographic, and relevance features are basically independent. We basically do a test sort of which variables matter for the rank. And we see that among the people with the same education, experience, and so on, gender is still a significant predictor in the search result list. And this is essentially what we find on all the three sites. So what's the takeaway here? Basically, that beyond the differences that you would expect, based on women having, on average, sort of weaker resumes, maybe, there's an extra effect. And even across men and women with the same exact qualifications, men show up higher in the result list. But of course, it's very hard to know why this is happening. It might be that the algorithm learns from some hidden features that correlate with gender, or it might be, for example, that the recruiters in the past have already clicked more on men's profiles subconsciously, and then the algorithms take that into account and push men higher up in the list. So we don't know it, but it likely affects hiring decisions, because when we look at related work on how much more likely people are to click on, results that are ranked higher, the difference is quite big. Maybe a final thing that I'm going to show you is that we actually tried to dig a bit deeper into where these gender differences are coming from, and came up with variables that are not directly specified on the profiles, but that could reasonably affect the outcome. So this was really just to test, is there maybe an effect of things that we don't see, such as, for example, listing Harvard on your profile, or having a longer resume, or how often do you switch jobs, and so on. So here we used the traditional auditing method. We actually uploaded resumes where the only differences between them were exactly these features that we were interested in. And the takeaway is that we can actually find a couple of hidden features that are used in the ranking as well, or at least correlate with the ranking. And of course, these might also correlate with gender. So But we see that gender directly is not taken into account by the algorithms. So in short, we can say that hiring sites do use these hidden features to rank candidates. They might correlate with gender. This could be one of the explanations for the results that we saw previously. Okay, so what you see here is a freelancing platform. We can ask very similar questions in the context of freelancing platforms, or actually in the context of any website that collects profiles in some form. For example, where you would find someone to help clean your apartment or take care of your job or find a nanny or so on. And in fact, on these websites, there is much more interaction between employers and employees than in the previous example. And really a lot is based on what you show in your profile. So there's even more space for biases, I would say, to enter the system. So for example, when I search for freelancers in my town who could help me with organizing an event, this is the list of profiles that I get. And once I click on someone's profile, I see even more information about them. So I see a little bio, I see their picture, name, description of themselves, and so on. And people who are successful on these websites actually fill out these profiles quite elaborately. And of course, another super important ingredient is reviews that other people have left for these workers. So you can see how both in the choosing who to click on and the reviewing process, conscious and subconscious biases or stereotypes could enter. All the profiles make the demographic information visible on most of these sites. And then on top of it, there is an algorithm. So it's really challenging to disentangle what's going on. But the main question in this project was how demographic features relate to social feedback. So these reviews that you see, or the position in the search result page of the workers. I'm not going to go into more detail about this project. You can read the paper if you're interested. But basically, it's a very similar measurement to the previous one. And rather, I will say something more general about the measurement methodology for these types of auditing. So because it's a bit different from the one that I described in the first part of the talk to measure personalization. So here I basically scrape data from the websites. For example, in the case of freelancing, I picked 2 different freelancing websites. I scraped data about user profiles and anything else that's available. For example, in that case, it was where people show up in the search result list. But in some other cases, it could be a website that also has some kind of social network, and then I would also collect the social network data, who's connected with whom. Or in some other professional communities, you also see kind of more detailed interaction between people. So basically, first in the data processing step, we need to associate some kind of meaning with the data. For example, extract race, gender, experience from the profiles, sentiment from the reviews, or relevance of a match between the employer and employee. And then we need to quantify differences between the outcomes between users or groups of users. And for this, we use statistical methods, basically often used in economics or sociology. And finally, the real challenge becomes then to disentangle where these differences are coming from. So depending on the websites, my papers would find inequalities due to the way people present themselves in their profiles, or the way they behave through these rating systems. So number of ratings people get, or how people describe each other in those ratings, or how people select the workers from a recommendation list, or differences can be actually due to very subtle design decisions as well. I wanted to show also an example for one of these subtle design decisions on Stack Overflow, but I think I'm running out of time, so I'm going to skip that part. Maybe I'll just say one sentence about it. So what we found here was that Stack Overflow actually rewards answers to questions twice as much as the questions themselves. So people collect these points on Stack Overflow, and it's like a super important thing on their profiles. And, you know, if a recruiter goes on Stack Overflow trying to find someone, trying to hire someone in IT, they will actually look at what's the reputation point of people. And so what we found was, first of all, that men are on average much more successful on this website regarding these points. But then we found out that it's mostly happening because of this one seemingly small behavioral difference, that women are much more likely to ask the questions and men are much more likely to answer the questions. And the points that you get for that is completely different. So really just a quick example for how some kind of design decision that the website makes without really thinking about it can really affect the outcomes in a very significant way for different groups of people. Okay, 2 sentences about challenges. So challenges of auditing online platforms are first that it really doesn't scale. So as I mentioned, every website is different, and not only the tools for the data collection, but also the methods for the analysis and the types of mechanisms that we have to study are different on every single website. On some sites, the social network effects were large, on some other ones, the feedback system. So we need to kind of adapt the methodology every time. And of course, we only see one market and its current audience at a time. So it's not only hard to scale, but it means that what I presented so far was mainly about identifying an issue at one point in time, but it's not yet a structured and long-term external audit that would really give some guarantees to users. And finally, I hope you had been thinking this all along, but there are a bunch of ethical aspects to this kind of data collection. Maybe we can talk about this in the Q&A part. So we often also even worry about publishing the names of the companies that we audited. So these questions are really something to keep in mind, especially when we teach students about scraping. And maybe the last point is that I was talking a lot about algorithms, but really they are just an excuse to study social processes in depth in online contexts, because it's really the people who create the bias. And I think there's one slide that I have to skip, which I just wanted to mention that as basically a solution to all these challenges about not scaling and platforms changing over time. In the recent years, I've been really focusing on creating simulations that can actually be a super useful tool to complement this type of data collection and actually try to figure out how to mitigate the problems and how the systems would evolve over time with certain interventions implemented, and so on. So if you're interested, you can look up also more recent papers from our group, which use simulations as a tool.
Thank you all for being here. Thank you so much again to the speaker, the host, and everybody who asked questions. And we look forward to seeing you again sometime soon. Thanks and bye-bye.